Okay, so for summation notation, continuing 9-4, this says we use the Greek capital letter sigma, which looks like the E. It's called a sigma to indicate a sum. The least and greatest values of n is going to be your limits. Okay, what that means, the n is the number of term in the sequence. Okay, so it's the limits go from here. They show you the limits. This is the lower limit. The first term in the series begins with this first term, n equals 1. So you're starting with the first term, that's what this means here, and going to the 108th term here. The last term in the sequence is going to go in the upper limit. The formula here is the explicit formula. That's what you use to find any term in the sequence. Okay, so for this one, 1 squared is the first term, 2 squared is the second term, 3 squared is the third term. So the formula is n squared. So if you're looking for the 9th term, it would be 9 squared. You would plug it into that formula. Okay, the reason this is 108 isn't because this is 108, but because this is the 108th term. That's why 108 goes at the top. Okay, so what is the summation notation for this series? In order to find the summation notation, we're going to have to write it in that form. You have to n equals 1 at the bottom. What goes here is the rule, and what goes up here is how many terms you're adding in the sum. Okay, this 207 is the last term, but I don't know what term number that is. Alright, and what we're going to first start, we're going to get the rule or the formula by using the AN formula. And I'm going to plug in the first term and the common difference, and that will give me my explicit formula. So the A1 is 7. N minus 1, my common difference here is 4. Distribute the 4, 7 plus 4n minus 4. 7 minus 4 becomes 3, so my formula is 4n plus 3. So that's what goes here. Okay, now I need to find out what term number the 207 is. That's going to be your AN. I know 207 is the last term, so I can plug that in for the AN and solve for n, and that's going to give me what term number it is. So subtract the 3, 204 is equal to 4n, divide by 4, and n is equal to 51. So that's what's going to go up there. This is the summation notation for that sequence or that series. You can try on your own now, or you can try them at the end. So this first part, if an explicit formula, that should say formula, is a linear function of n, then the series is arithmetic. Okay, so what that means, if your explicit formula in the summation notation is in linear function form, which is y equals mx plus b, then the series is arithmetic. The slope of the line is going to be the slope of the linear function is going to be the common difference. Okay, just to let you know about that. So what I'm having here is I'm trying to find the sum of the series written in summation notation. Well, to find the sum, I'm going to use the SN formula. SN is equal to n over 2 times A1 plus AN. The n represents how many terms that I'm adding. Well, that's going to be found from the top. I'm adding from 1 to 70, so it's going to be 70 over 2. Now to find the A1, what you need to do, that's the first term, and what you can do to find the first term is plug 1 into the explicit formula. So 5 plus 3 is equal to 8. 8 is going to be that first term of that sequence. To find the last term, well, in this case, that's going to be the 70th term. So I'm going to plug in 70 in for n. 70 times 5 is 350, plus 3 becomes 353. So now you're just going to simplify. It's the sum of the 70 terms, so it's 35 times 361, 8 plus 353, which becomes 12,635. So that's the sum of this series. Okay. Well, this one, it isn't technically an arithmetic. It's not an arithmetic sequence, so you can't use that SN formula. Okay, you could list them all out and find the sum that way. We're not going to do that one today. So in the U-try problems, just do number 5. The other two are not arithmetic either because they're not in the form. The explicit formula isn't in the linear function form of y equals mx plus b.